is just a reminder about certain things. Pick up the vocabulary. You just should know these words. And then the box at the top of page 604. Let me pull out that and make sure you recognize what it is I want that you need to be able to have. And you just simply are going to have to memorize some of these terms. You all know triangle. Well, that page too. I hate it when something is right on the edge like that, but let's see now if I can zoom into it. Okay. Okay, doesn't show up very well with this tuning on this, but let's see if I can get to it. Okay, this box here on the top of page 604 tells you if it has 3 sides, it's called a triangle. 4 sides, quadrilateral. If you did 4 sides and called it, well, I can't quite call it a rectangle because you don't know for sure that it is. But that's the best term, quadrilateral. Pentagon, hexagon, you just need to memorize those, right up to dodecadon. And I mentioned or wrote in this paper, you don't need to remember 11. Hendecagon, I see that word so seldom that I'm giving you a break from that. You don't have to memorize an 11-sided figure. You don't see them very often anyway, and I'm not planning to put that on my tests, so you can ignore 11 sides. But make sure you know the rest, because I'm going to give you something on the test, some figure, and you're going to have to tell me the number of sides. And I'm going to expect you to remember it, and I'm going to expect you to spell it right, too. So a misspelling on this will lose you some points, because you're at the point where you can spell. And if you can't, then you better practice it, because, you guys should be able to do that now. Okay, and now I want to talk about this one. Oops, let's come down. When I say name and classify, there are 3 parts to that. You have to do it based on the number of sides, based on whether it's concave or convex, and regular or irregular. So I'm going to actually put a couple of examples up here. Let's see if we get a couple that I had drawn up myself already. Where is that? Okay. I'm going to start with one. Looks like this. And I'd recommend to draw something like this so you have an example or a reminder. Okay. So what I've done here is I've drawn sort of a house type of thing. Put the top on it like that. Sides, go in a bit, and then do a partial triangle there. So I first have to name it based on the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. Now I really, as I started doing that, I realized I probably shouldn't put dashes like that, because if I put dashes like that, what I'm telling you is that that length is the same. I guess I can get away with that because I sort of did make them all pretty much the same. So the lengths may all be the same. So what we next need to look at here, number of sides, oh, there's 9 of them. That means it's let me make sure I get it right so I don't mislead you on it, nonagon. There's other terms you sometimes hear for it, but I want you to stick to the one that's in the book. So that's 9 sides. It helps that it's an and. That helps to remember that. So that's number of sides. Concave and convex are easy to remember if you just remember that the word cave means that you have a part that's cut inside of it. And therefore convex would be one where it's not cave. So something like a triangle is not concave, but rather convex. Not possible to have a concave triangle, but all the others you could. You could have a concave something. So this one's concave. Oops, that one. And regular or irregular. Well, a regular one is when all of the sides have the same length and all of the angles have the same measurement. So right here you can see here's a big angle. Down here you have a couple that are different from that. So the angle measurements, and here's one that's really huge, the one around that one. All those angles, many of those angles are different. That means if it's not regular, automatically it's irregular. So as the textbook shows you, regular means that the lengths of the sides all have to be the same and all of the angle lengths, or angle amounts have to all be the same as well. So this one's a nonagon, it's concave, and it's irregular. Now, let me try to draw one that's a regular one. It's a little harder for me, but one that you would recognize as a normal shape is a stop sign, or what we think of as a stop sign. That's one that has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. So 8 sides is an octagon, plus, because when you see that they're all in that sort of circle there, all of these angles are the same. This is also the way we show them. The slashes tell you the lengths are the same. The little arcs tell you that the angle amounts are the same as well. So this one is an octagon. And it's convex because, very simply, there's no cave in it. There's no part in it that digs into it. And it's regular because all of the lengths are the same and all of the angle amounts are the same. So those are 2 examples there. You're going to have something on the test like that. You have to get them all right. This is not one where you really should have partial credit. You should be able to get all of them right because concave or convex and regular and irregular are really easy. And the names, you're on notice that you should know those names. So this should not be a hard thing to do. Okay, the next part of this, down here, we'll move down the bottom of the page. And the formulas. Well, the basic formulas, I'm going to say, yes, you should have memorized, but you should have these memorized already, because this was middle school math from a while ago. When you look at a triangle, actually for any of them, the perimeter is just adding up the sides. You don't even have to think about it as a formula, except for circle. But for a triangle, remember that it's the 1/2 base times height. That is going to help you in a number of ways, including some of the problems we get in actually coming up next too. And a square, actually I'm going to jump to a rectangle, because remember that's length times width. Well, a square is nothing more than a rectangle. So rather than thinking of a square as specifically, the little rule they give is a side squared, squaring the sides. Well, in a reality, that's just length times width anyway. So you don't have to memorize s squared for square, even though it's got it in the book and it has it in a bunch of other places. You can just do area equals length times width for any 4-sided figure. That's a rectangle, and a square is a rectangle. And for a circle, this is the biggest problem, is people get mixed up with the square or not square. So when you have the area, that is equal to pi r squared. And the square should give it away, because remember, area is always based on square. If you're talking about inches, it's square inches. It's like there's little squares inside something. And that means you have to call it squared. And you're multiplying 2 things, so you get that unit squared. When you do the circumference, which, by the way, if you forget, circumference, yeah. If you forget what circumference means, just think of it as the perimeter. Because perimeter and circumference are the same thing. It's just perimeter for a circle, we just use a special name for it, essentially. Partly because circumference means a rounded figure, so it comes from that. So the circumference is equal to the same thing, you just put the 2 in front. So it's 2 pi r. And some of you had learned it originally as the diameter times radius, or RD, I guess, doesn't matter. You can remember it as RD, diameter times the radius, but it doesn't matter to me. Just make sure you don't get these mixed up. Personally, I remember it this way better, just because I think of the differences for them to help you remember it. Okay. And you'll get used to a circle that one time around a circle, if the radius is 1 time around a circle is 2 times pi amount. You will get very used to that in integrated 3, because that's the basis of trigonometry, is that 1 time around a circle, what we call the unit circle, is a distance of 2 pi, which is 6.28. 2 times 3.14 is 6.28, with all the little numbers after it. Approximately 6.28, to be more exact. Okay. Now, let's go look at the next page. I gave you a graph on the next page. Okay. One of the standards that we meet this year in Integrated 1 is to do geometric figures, find area and perimeter of figures on a coordinate plane. That's actually a lot easier than if you don't have a coordinate plane, okay? And I'll show you how. Let's mark these points on here. That's where A is. B is at, B is over here at 3, 0. C is at 2 and 4. And I'm going to draw this. Now, one of your lessons is the distance formula. I think we already did that. And you can use the distance formula, because right here for A we have negative 3, 0, and for C is 2, 4, and B is 3, 0. So we could find the distance here by doing x minus x squared plus y minus y squared. Nothing wrong with that at all. When you have it a coordinate plane, though, you have it even easier. I am going to make a triangle here. I'm going to say that the length of AC is equal to, if you think about it, this length here, this is the distance, and this distance, you have a right triangle if we come down here and go over here. And that right triangle has 1, 2, 3, has 5 here, and it has 4 here. So what we have is the square root of 5 squared plus 4 squared. Now how I came up with that is actually, if you think about this as c squared equals a squared plus b squared. Or a squared, I usually make it smaller. C squared is equal to a squared plus b squared. So c squared is a squared plus b squared, but I don't have that squared. I'll just square root this both sides immediately. So a squared plus b squared. AC is equal to 25 plus 16. AC is equal to 30 square root of 41. And you do need an approximate there because you can't really add up square roots there. So if I do the approximate, I figured this out on my calculator already, but if I can't find it, I'll have to do it again. So the square root of 41. So make sure on whatever calculator you use that you know where to get the square root button. And that's the kind of thing you need to know before you start a test. So you bring your own calculator or use mine and make sure you're comfortable with that. So the square root of 41 is approximately 6.4 and all that. 1 decimal place is enough. So approximately 6.4. And then we're going to look at the other ones. This is one side, but now we know that's 6.4. We need these other two sides. This one here, A to B, is really easy. Because for AB, it's already on a vertical line. Just count. 1, 2, 3, 4, 5, 6 is equal to 6 units. I have to call them something, so we'll call them units. And then we need to know what AC is. So for this, you can use the distance formula again. 2 minus 3 squared plus 4 minus 0 squared, and take the square root of that. Well, I'm going to go halfway. I'm going to do that already with 4 and 1. Because if this is C, I'm going to do, well, I guess we'll do C squared is equal to a squared plus b squared. So it's the square root of 1 squared plus 4 squared. 16 plus 1 is square root of 17. And the square root of 17 is going to be very close to 4. 4.123. So that's approximately 4.1. So we have 3 numbers to add up. So the perimeter is approximately 6.4, 6, and 4.1, and you add them up. 0.5, 10, and 6, so 16.5. Okay, 16.5 units. Actually, that's what I want to box up there. Okay. Let's see. Right. Okay. 41, 25, 35, 41. Okay, I guess I'm good on there. Okay, so that part isn't really hard. The area is even easier. Area is 1/2 the base times height. Base times height. Here's the base. 1/2 times 6. 1, 2, 3, 4, 5, 6. The height is 1, 2, 3, 4. 6 times 4 is 24, divided by 2 is 12, or I can do 2 goes into 6 3 times, so that means it's 12 units squared. So the area is 12 units squared. This is what you have to do if you have a coordinate plane. It's not hard at all if you have a coordinate plane. If you don't have a coordinate plane and you're just given the numbers, then you have to do the x minus x squared and y minus y squared, do the distance formula. That's not all that hard either. It's just even easier if you do a squared plus b squared. Now, one of these here had the AB, had this given to you. That's an easy one already, and by having that and this, it makes the area really easy.